Hi guys, it's Andre from High Performance Academy. Welcome along to another webinar. And in this webinar, we're going to be discussing blow-by from your engine. And there's a common misconception often when we're viewing an engine, particularly if it's running on a dyno and we're actually able to view what's coming out of the catch can or breather system of that engine. There's a common misconception that basically any amount of blow-by exiting through our breather system indicates that there is a massive problem with our engine. And I've seen a lot of people get needlessly worried about this, and I've seen a lot of people also end up stripping engine components down just due to this and finding out that there was actually nothing wrong. Now, before we get too far into it though, that's not to say that in all cases blow-by in our breather system doesn't mean we've got an issue. Let's jump across to my laptop screen for a moment. And this is just a quick YouTube video that I found without too much difficulty. And this indicates that, yeah, we probably have got a problem. Someone's just removed the oil cap from this particular engine. And this engine's just sitting at idle. We can see the amount of gas being evacuated out through that filler cap, and yeah, this would definitely be indicative that we've got a problem. But if we've got our engine at idle and we remove the oil filler cap like that, generally we're still going to see some amount of pressure being released through there. That doesn't necessarily mean we've got a problem. So let's find out what exactly our breather system is, find out what we need to know. We're also going to talk a little bit about the modifications that we are likely to need when we are modifying an engine to increase the power level, maybe adding a turbocharger to a naturally aspirated engine, or even taking a factory turbocharged engine and massively increasing the boost in order to make sure that our breather system is up to the task. Now, let's start by just talking about what our breather system is. So every engine, either factory or aftermarket, is going to require some kind of breather system. Most often this is going to be attached to the rocker covers. We've got our SR20 rocker cover here, which we're going to be using, looking at in a little bit more detail shortly. We've got a couple of breathers on the back of the rocker cover, and we also have a Pcv, positive crankcase ventilation valve on the rocker cover as well. So this is the sort of breather system that we're likely to find on a factory engine. And the reason we need this breather system is that regardless what condition your engine is in, whether it's in pristine, perfect condition, or it's just about on its last legs and it's suffering from serious damage, we are going to see some amount of blow-by occurring. So blow-by is simply the combustion pressure escaping from the top side of the piston down past the rings and making its way into the crankcase. The amount of blow-by we get though is what we're going to need to be concerned about here, what we need to be worried about. And the amount of blow-by that we're going to see from an engine is going to be affected by a number of aspects. First of all, we need to consider the condition of the ring seal. We also need to consider the piston ring end gap, and this is particularly a consideration with modified engines. Often the piston ring end gap will be greater than a factory engine, allowing a clearer path for our combustion pressure to escape down past the rings. The other thing that we need to consider as well is the stability of the ring pack. In other words, how well the ring pack is stabilized against the piston ring grooves as well as the cylinder wall. Now, the problem we have is that as we increase the amount of power that we're producing from an engine, so in other words, as we modify a factory engine and produce more power from it, the reason we're making more power is that we're creating more cylinder pressure. It's that pressure acting down on the top of the piston that's going to end up producing torque at our crankshaft. So in order to make more torque and power, we need more cylinder pressure. As we increase the cylinder pressure, naturally, even when the engine is in good condition, this is going to result in more of that combustion pressure escaping down past the rings and making its way into the crankcase. So the more cylinder pressure we have, the more blow-by we have, and we obviously need a way of evacuating that blow-by out of the crankcase, and this is where our breather system comes in. So when we've got a factory engine, the breather system is going to be designed for that factory engine, for the sort of crankcase pressure that the OE manufacturer is going to expect. The other thing is that in a stock engine, often we don't have significant amounts of blow-by to worry about in comparison to an aftermarket engine using forged pistons. Part of the reason for that, as I just mentioned, with aftermarket rings, we're likely to end up using slightly looser piston ring end gaps. The other thing is, with forged pistons, we're going to need a larger piston to cylinder wall clearance when we're assembling the engine. Now, when the engine is up to operating conditions, operating temperature, this is not a significant concern, because the reason we allow that additional clearance between the piston and the cylinder wall is so that when the piston expands, it achieves the correct piston to cylinder wall clearance. The downside, though, is that when we cold start the engine, the piston to cylinder wall clearance is excessive until it warms up, and this doesn't do quite as good a job as stabilizing the ring pack against the cylinder wall, and this can result in an increase in blow-by even when the engine is cold there. So in a stock system, because the factory breather system doesn't necessarily need to cope with so much blow-by, the breather system is generally relatively small. The other problem or issue that we have with the stock breather system is that inevitably the result of the breather system, all the blow-by gases do get vented back into the intake system of the engine, and this is an emissions requirement as well. So ultimately there may be an oil-air separator somewhere in the system, and then finally the blow-by that is remaining gets vented back into our intake system. If it's a turbocharged engine, this will be pre-turbocharger. If it's a naturally aspirated engine, generally it's going to be somewhere after our air filter system. So the upshot of this is, when we are running a factory car, if we pop the hood, the bonnet on the engine, on the car I should say, when the engine is sitting there at idle, we're not going to physically see any blow-by. There's nothing to physically see, because in a factory car we don't have a catch can with a big filter sitting on the top, so we can actually see what's going on like we do with an aftermarket engine or breather setup. So this means that we don't often have a really good baseline to compare what amount of blow-by is occurring in a factory engine compared to our forged aftermarket engine that's been built with aftermarket components. So this doesn't give us a great comparison there to start with. What I'll do here is just quickly go over a couple of features that we've got on this SR20 VE rocker cover, which is pretty typical of a standard breather system. So it's a aluminium rocker cover, and we've got a couple of breathers here. We've got one at the back of the rocker cover. Let's just go to our overhead camera here. We've got a breather at the back. We've also got a breather which actually ends up being on the turbo side of the rocker cover. And then we've also got on the inlet manifold side, we've got a further breather here. Now this particular breather that we're looking at there on our inlet manifold side is referred to as a Pcv valve. This stands for positive crankcase ventilation. And this is kind of a catch-22. What it has inside it is a one-way valve. So what it does is it allows any positive pressure inside the rocker cover, which also connects to our crankcase, to vent out through that breather when there is a lower pressure in the inlet manifold compared to our rocker cover. So this would be idle or when we're cruising, for example. On a turbocharged car though, as soon as we've got positive pressure in the inlet manifold, this Pcv valve is actually going to shut off and it's not going to do anything. So often we will only have or only see two breathers from a rocker cover. One will be the Pcv valve, and then because this is not going to be useful to us when the engine is under boost, we've effectively only got one breather occurring or operating under high boost, which is the exact conditions where we are going to be producing the most blow-by. So that can be problematic in a stock breather system, one of the reasons why we need to modify it. Now, I just want to show you one more thing as well, because this is something that's often overlooked and is the reason for a lot of the problems we see with aftermarket breather systems. If we flip this SR20 rocker cover over, we'll see that on the underside of the rocker cover, we've actually got an aluminium baffle plate fitted. Now, the reason this baffle plate is here is to aid with separating the oil vapor and the air. And quite often I see in the aftermarket that a rocker cover like this will be modified with larger breathers. There's nothing specifically wrong with that. In fact, we're going to talk about that shortly. But in order to do that, we're going to need to drill some holes in the rocker cover, maybe use a die grinder to open out the existing breathers. Obviously, that's going to result in a lot of debris being produced. We don't want that inside our engine. So a sensible approach here is to drill out all of the little rivets that hold this baffle plate in place, so we can clean out the rocker cover. That's all fine, but more often than not, after that's been done, the baffle plates are not replaced. Now, why that baffle plate is there, as I mentioned, is to help separate the oil and air so that we predominantly have air exiting through the breather system. When we don't have that baffle plate there, we don't have that effect. So what we end up with is a lot more oil droplets being incorporated into the blow-by air that's going out through the breather system. So that can be problematic. We can end up filling up oil catch cans with liquid oil, which can be problematic. Okay, so the results we get with our factory breather system, because the blow-by gases are inevitably recirculated into the intake system, this is also another problem that we have with a factory engine. The reason this is a problem is because that oil vapor isn't a great fuel. It's going to be incorporated with our intake air. It's going to make its way into the combustion chamber along with the fuel that's being injected, and it's going to burn. And the effect of this is that the oil vapor tends to reduce the overall octane rating of our fuel air charge, and particularly in a high boost turbocharged engine, this can possibly be enough to push us over the edge and run us into detonation. So we don't want any oil vapor making its way into the intake of the system if we can avoid it. The other obvious issue is because we are running oil vapor continuously through the intake system of our engine, over time this builds up a lot of residue and gum in the intake system. It can, depending on your intake system, it can actually affect the operation of aspects such as your idle air control valve, although this is something that's going to require a considerable amount of time to deteriorate, but it is something that you do need to watch. It also will end up baking onto your intake ports and baking onto the back of your valve. So again, over a long period of time, it's actually going to have a reduction, an effect of reducing the airflow into your engine. So obviously not something that we want to be dealing with. And essentially when we are modifying any factory breather system, unless there is a reason to do so, we don't want to be reintroducing that blow-by back into the intake system. So in the aftermarket, one of our common modifications with the breather system would be to run our rocker cover breathers out into a catch can. Now, this is a good thing because it fixes that problem that we've just been talking about. What it does is it removes our oil vapor from the intake system of the engine. We're no longer introducing oil vapor into the intake charge, and again, this reduces our chance of detonation and also reduces the chance of our intake system becoming gummed up with oil residue over time. The problem is that now, because we've got that filter on the top of our catch can, we actually have the ability to see what's going on. We can physically see all of that blow-by gas escaping through the filter on our catch can, and this is where that worry can come in. So it can definitely be a sign of engine damage, and that video that I showed you at the start would be a good sign. So if we get excessive blow-by, this can be the result of a few aspects. First of all, it can be the result of some damage to our piston. So this is a pretty good indication of piston that would have resulted in a massive amount of blow-by. This is a piston where the whole site has been melted out of it due to very, very severe detonation. combustion. So of course, when we've got something like this occurring, we've got a straight path straight through the side of the piston down into the crankcase. So this is going to result in a massive increase in blow-by. It's also going to almost inevitably push a lot of oil out that breather system. So you're going to know about this sort of problem very, very quickly. Slightly less severe compared to that would be a situation where we've maybe cracked the ringland on a piston due to detonation, and again this affects the ring seal and can end up with excessive amounts of blow-by. Also slightly less severe amounts of detonation than what we've seen on that piston, and also just generally a reduction in our ring seal that's going to happen over time. So all of these aspects will build up to increase the amount of combustion pressure that's making its way down into the crankcase, and then in turn being vented out through our rocker covers, through our crankcase breathers, and finally into our catch can. So the problem we do need to understand is that when we've got a modified engine, we are likely to see more blow-by coming out through our breather system than what we'd see with a factory engine. It's just an aspect of the way the engine has been modified. And when I often see people complaining or worrying about whether their engine is damaged, it's been the result of them attending a dyno session where they've been standing there watching their car run up on the dyno, and under these conditions the car is running under sometimes high boost pressure and also high RPM, but because the car's stationary there on the dyno, most often with the hood or the bonnet popped up, you're physically able to see something that under normal conditions you wouldn't be able to see. And what we've got is people comparing this situation, all of this blow-by that they're seeing come out of their catch can, to no baseline. They haven't got a baseline of what a good engine should be. So it obviously looks worrying, but remembering again that as we increase the boost pressure particularly, or increase the cylinder pressure, we are going to see more blow-by come out of a breather system regardless what the condition of the engine is. The other problem we've got, I've touched on this, but I just want to go into in a little bit more detail, is that if we are modifying a factory engine and we haven't done our job properly and we haven't dealt with the factory breather system, and then we've gone and produced a significant increase in power, maybe we've added a turbo to a naturally aspirated engine, obviously as we've already discussed, this is going to result in an increase in our blow-by. The result of this though is because the breather system is now probably way too restrictive, way too small for the volume of blow-by gas that needs to be vented, this increases the velocity of those blow-by gases. So the air exiting through the breather system is physically moving faster, and this means that it is now much more likely to be picking up oil droplets from inside the crankcase, from inside the rocker cover, and taking that oil with it. So this is why we often see an ill thought out breather system quite quickly fill up a catch can in competition use with oil. It still doesn't necessarily mean that we've got a problem with the engine. It more often than not, in my experience, indicates that we've just got a poorly thought out breather system that needs some modification. So now what we'll do is we'll talk about what we actually need to consider, what we need to do with our breather system in order to make sure that we've got a fighting chance of keeping the oil in the sump. We don't want to be filling our catch can every time we go out on the racetrack or do a pass down the drag strip. And if we do all of this properly as well, it is going to reduce the obvious signs of blow-by that we're going to get. So what I'll do is I'll go through this list here, and then I'll actually show you through what we've done on our Toyota 86 development car to address exactly these aspects and talk about how that was integrated onto the car. So the first thing, remember I've talked here about the size of the factory breathers not being sufficient. So obviously a solution to that is to either increase the size of the factory breathers, or better still, even add additional breathers. At the same time, what we can do there is add a crankcase breather, as well as the factory breathers that we'll always see on our rocker cover. So if we can just jump across to my laptop screen for a moment. This is a little bit out of context, unfortunately, but I'll try and explain what we're looking at here. This is the side of a Bullet Race Engineering billet aluminium 4G63 Mitsubishi engine block, and what we can see here is a massive breather that is machined into the bottom of the crankcase there. So just so you've got some perspective if you're not familiar with this, down here, this is the sump rail. So if we actually look up, this is moving towards the deck surface of the block. So this is just above the crankshaft line, and we've got this massive breather, and this can be used to vent out to a catch can. So this just helps increase the amount of blow-by gas that can be removed, particularly with these Bullet Race Engineering 4G63 billet blocks being used in applications running 80, 90 or 100 psi of boost or more. That's obviously going to result in a massive amount of blow-by. So this is just one example of what you can do to help combat that blow-by. All right, I'll head back across to my notes now for a second. So the other thing we can do when we are dealing with a factory rocker cover like this, where we have our Pcv valve, as we've already discussed, that Pcv valve is going to be of absolutely no use to us when we are running under positive boost pressure. So it's reasonably easy and reasonably common to remove that Pcv valve and then fit an extra breather from that valve, run that into a catch can, and then that particular breather on our rocker cover is going to function regardless whether we're under vacuum or under boost. Next, I want to talk about the catch can a little bit, because we do want to fit as large a volume catch can as we can into our engine bay. Now, if you are developing your car for competition use, often you'll find that your governing body may have minimum requirements for the size of the catch can. For motorsport New Zealand events, circuit events that we compete in here in New Zealand, we need a minimum capacity of about 2 litres for our 2 litre turbocharged engine. Also, as I've mentioned there, we want to make sure that we baffle the rocker cover, or at least incorporate the factory baffle plate, so that we're not just dragging raw oil vapor or droplets out with those blow-by gases. So this just again comes back to replacing that baffle plate if you're removing the factory one. If you are adding additional breathers, you can make up your own baffle plates and attach this to the underside of the rocker cover to help reduce that blow-by, or reduce, I should say, the blow-by gases pulling oil through. The other thing we want to also consider is what happens if your catch can does fill up. So this is a very real concern, and this may be the result of just a ill thought out breather system. It hasn't followed what I've talked about there, and it is dragging too much oil vapor out into the catch can. But of course it can be the result of a partial engine failure or some kind of damage to the engine that we may not immediately be aware of when we're out on the racetrack. Now, if we don't give this some thought, we may get into a situation where that catch can may overflow. It may end up dripping oil down onto hot components of the exhaust system, which could end up catching fire. Or the other thing that can happen is the oil may end up getting under the car and making its way between the tyres and the racetrack. So obviously all of those situations we want to avoid. And a number of the high-powered turbocharged drag cars that I was involved with, these actually, for that exact purpose, ran a catch can that was fitted into the trunk area, the boot area of the car, and this required a lot of work obviously to run tubing from the engine bay all the way back into the back of the car. But the advantage with it was that if that oil catch can did overflow, it did fill up, it's simply going to be dumping onto the track. That's not ideal for other competitors, but it at least meant that there was no chance of that oil making its way onto the tyres, giving the driver a fighting chance of actually controlling the car. Alright, so what we'll do is we'll just head across to my laptop screen. I just want to give you a little bit of a tour of our Toyota 86 so you can see what we've done with our catch can system. So this is a factory naturally aspirated 2 litre engine that we've added a turbo kit to. It runs a Borg Warner EFR turbocharger using predominantly an AVO turbo kit that's produced in Australia. So the turbocharger is actually out of sight. It's mounted quite low down in front of the engine there. We'll see that from another shot shortly. So considerations for us with this particular job is we're taking a factory naturally aspirated engine and we're adding a turbocharger to it. While we haven't touched the engine internally, we do know that we're going to be producing a lot more cylinder pressure. As we've already talked about, the upshot of this is we're going to be increasing the blow-by. Now again, out of shot, one of the factory breathers that sits down at the back of the FA20 engine is a Pcv valve. So again, we don't want that Pcv valve to be blocked off when we're under positive boost pressure, and we don't want it to be venting back into the inlet manifold. So that was replaced with an AN fitting which adapted it to a -10 hose. So what we've done is we've fitted a catch can that's visible over in the right rear of the engine bay up beside the battery, and this particular catch can is around about 1.5 litres in capacity. So unfortunately we couldn't physically fit anything larger into the engine bay. So we've got one, hopefully we can just see that. Actually I might be able to zoom in a little bit and see if we can see it a little bit clearer. Okay, so on our catch can, what we can see is we've got two breathers on this side, and two hoses entering on the left and one on the right. So on the two that we've got here, one of these comes from the Pcv valve location that I've already talked about over here at the back of our engine block. So this takes blow-by gas directly from the bottom of the sump. There is another factory breather, which again, just due to our tight engine bay, is a little bit hard to see. It actually sits in behind the air conditioning compressor here. So those two both go directly to our catch can. Now, because I wasn't confident that that was going to be sufficient for this particular application, we also went one step further and we've added an additional breather system which comes off the oil filler cap. So we'll just jump across and have a look. We can jump across and have a look at this. There's a closer shot of our oil catch can, and what I wanted to show from this is we've got on the bottom of it, a little bit hard to see, we've actually got a drain. I'm going to talk a little bit more about that drain in a second. And we've got 1/4 breather, which is actually entering into the bottom of that catch can at 90 degrees, and that comes from the turbo oil drain. Again, we'll have a look at that in a little bit more detail shortly. I just wanted to focus again on this extra breather that we've added. So what we've got here, this part comes from AVO. We've just modified it a little bit. What it does is it uses an aluminium CNC machine spacer that sits underneath the oil filler cap. It's got a special oil filler cap that goes along with this, and what it does is it lifts the oil filler cap and allows blow-by gas from the sump to make its way out into this -10 breather. So what we're doing there is we're adding in effect, under boost, we've got two additional breathers from the crankcase over what the factory engine would have. We've got this one here which never existed, and we've also turned our Pcv valve into an additional breather. I just want to show you the underside of the car as well, because this again is a little bit unique. So this is a shot from the underside with our radiator support panel up the top of the shot here. So we can in this shot see our Borg-Warner EFR turbocharger, and this is a problem when we are low mounting a turbocharger on any engine. We really need to be able to drain the oil from the turbocharger back in above sump level, and because we've fitted the turbocharger so low, this isn't possible. So what we've got here is a scavenge box. So the oil drains out of the turbocharger into this little fabricated box. There is a scavenge pump fitted to one of the intake cams that then sucks the oil out of that scavenge box and then returns it back into the engine. But a common problem that we see with turbocharged engines is that if there is significant amount of pressure acting on the sump, acting in the crankcase I should say, what this can do is make it a little bit difficult for the oil to return its way out of the crankcase, out of the turbocharger, and this can result in that oil pushing past the turbine oil seal. So we've got this additional breather which again we can just see in shot here, and that's the one that goes up and connects to the underside of our catch can. So this is what I would consider to be a reasonably well thought out breather system. Even despite the efforts that we've gone to there, we do still end up pushing a reasonable amount of oil into the catch can. And it's important to keep this in consideration and have a way of being able to drain the catch can regularly. And this is going to prevent that problem that I just talked about where the catch can fills up while we're out on the racetrack and we run into problems with oil potentially getting on the tyres. So let's just head back. So again, on my laptop screen at the moment, we can just see there is a little -8 line coming off the bottom of the catch can. And this was actually a pretty poorly thought out solution on my part, and I actually am partway through changing this. But initially what I wanted to do was actually return everything from the catch can, or have the ability to return everything from the catch can back into the sump. Obviously we can't have this happening all of the time, because when the crankcase is pressurized under boost, if we had this line physically open all the time, it's just going to end up pushing oil straight out of our catch can. So there's actually a ball valve fitted to this drain, so we can open or close that, and it's done manually. So the idea initially was to be able to open that valve after a session out on the racetrack. That would allow the catch can to drain down back into the sump, then we could close it off before the next session. If anyone's ever looked at what ends up getting collected in the bottom of a catch can, you may straight away sort of understand that that's actually not a particularly great idea. And given that this car runs on E85 as well, we tend to end up collecting quite a lot of water vapor in the catch can. So yeah, after sort of reconsidering, I decided, no, this isn't really what I want to be doing. So the end result of this is we're going to end up with that drain just running to the underside of the car, where we'll be able to drain it into a tray or something of that nature between rounds. On that note, I will mention that there are a few manufacturers who make these return style catch cans, but there's a little bit more goes into it. I know that Radium Engineering are one of those companies, but what they do is they incorporate coolant flow into the catch can from the engine. So this adds to your complexity quite significantly. The reason that they add coolant flow into the catch can, it's separate from the catch can or what's inside the catch can, is just used to heat the residue inside the catch can, and that tends to evaporate off any of that water vapor that collects, and this means that we are only returning oil into the sump. So just a few thoughts there. Right, we are going to move into some questions and answers shortly. So if you do have any questions on this, please feel free to ask them. Last topic that I wanted to cover is obviously, as we showed in that video right at the start of this webinar, excessive blow-by can definitely indicate that we have an engine problem. So how do we know if it's an engine problem, or how do we know if this is just normal behavior from our engine? The first point here would be getting to know your engine, building up knowledge of your particular engine. So if you're an enthusiast and you've started building up your knowledge of your engine, your car, from the day that engine was built and installed in the car, you're going to generally know if something has changed. So this is what we want to be looking for. We want to be taking note if anything is out of the ordinary. So we're not just taking the amount of blow-by exiting our catch can on face value and making all of our judgments based on this. Generally, the other aspect here is that if we have got a problem with our engine, if we've got a damaged piston that's resulting in a higher blow-by, generally it's not just the blow-by that's going to be your only indication that there's an issue. If you've got the engine running at idle, you're likely to find that the idle quality has suffered. It may idle rough, it may idle lower than normal. We may also find that it's an erratic idle quality, so we can physically hear that it's not running evenly on all 4, 6, 8, 10 or 12 cylinders, however many cylinders your engine has. So these two factors together would then be enough to indicate that, hey, no, something might definitely be wrong here. And the other aspect that I'd suggest here is that if you are building a competition engine and you've got a reasonable budget, a really good addition to the engine data logging package is a crankcase pressure sensor. This is something that we ran in a number of our drag cars. And what it does is it gives you data from the first day the engine was started and ran right through the lifespan of the engine, so you can physically watch what the pressure in the crankcase is doing and very quickly notice if something is outside of the normal. So this allows you to sort of build up a history of your engine. You're going to notice if something is starting to go away, if you're starting to get a problem that's going to become really apparent. You can set up warnings from your ECU or your dash based on this as well to immediately alert the driver to something's wrong. And again, you can use this over and above what you're seeing out of your catch can to really suggest that something is wrong. So lastly here as well is that if you do think you've got a problem, I wouldn't be jumping in straight away and pulling the engine down. There are some pretty simple checks that we should be able to do that are going to confirm if there's a more likely scenario that there is a problem there. So the two tests that I'm thinking about here would be a compression test initially, and even the process of going through a compression test can often give us some indication that there is an issue. For example, when we remove the spark plugs, often if we've got an engine mechanical issue, we're going to find one of the plugs showing signs of damage. Maybe it will be oily, maybe it will show signs of erosion from detonation or being run too hot. So these are all starting to add up to your arsenal of indications that something is amiss. The compression test on its own is relatively useful, but I normally back this up as well with a cylinder leakage test. So the compression test, what we're looking for here ideally is all of the cylinders on the engine to be relatively even. The actual numbers from a compression test, though, aren't particularly relevant. They will be affected by the cam profile of the engine or how much overlap we have with our cam. They'll also be affected by the cranking speed. So if you've got a battery that's in really good health versus one that's getting a little bit low, this can affect the absolute numbers from your compression test, as well as whether the engine is hot or cold when you've performed that test. A cylinder leak down test, on the other hand, is a much more accurate way of checking how well the cylinder is sealing. And on top of that, the cylinder leak down test also allows you to be a little more specific in whereabouts that leakage is occurring. In other words, you can listen to your oil filler cap or your breather system and decide if the leakage is making its way down past the rings into the crankcase, or alternatively whether it's coming out past the inlet valves or the exhaust valves. So it allows you to be quite specific there. Now, I actually jumped out of order for a little bit. One last thing I just wanted to mention here. I know I've already said one last thing, but one last thing is for serious competition use. It's also quite common to incorporate a dry sump lubrication system. Now, the main part of the dry sump lubrication system is that we're storing the oil remotely from the engine in a dry sump reservoir, and then we're using an external pump to draw the oil from our reservoir and pump it through the engine. So the key point there with the dry sump lubrication system is we're ensuring that regardless of the lateral or longitudinal G-forces being applied to the dry sump tank, we're always supplying the engine with a consistent, reliable, high-pressure oil stream. So that's obviously essential to our bearing reliability. The other aspect with this, though, is that generally our dry sump pump is going to also incorporate multiple, what is referred to as scavenge stages. So the scavenge stages are used to draw out the oil from the sump of the engine and pump it out into the oil reservoir. Now, it's not just scavenging out the oil, it's also going to be pumping out a lot of that crankcase blow-by. So with a dry sumped engine, we don't generally see so much blow-by remaining in the crankcase. If we're measuring the pressure in the crankcase, this is going to be significantly lower, sometimes even a vacuum compared to what we'd see with a wet sump engine. And for this reason, the entire breather system on a dry sump engine is quite different. We can incorporate no breather system at all on the rocker covers, and instead what we're doing is ventilating the the reservoir for our dry sump tank. So I just wanted to add that in there as well. In my own experience, our own drag car was running a dry sump system. It was a 4-stage Peterson dry sump system, and that took us from an engine that breathed very, very heavily under 50 plus psi of boost to one where there was no blow-by present from the breather system at all. So just to keep that in mind as well. All right, we'll move into some questions here. We've got a few of them by the looks of it. First question comes from Jordan, who's asked, I know of a guy who is having blow-by on his RB2530 with condensation in the oil catch can. If possible, could you cover this? Okay, so condensation, as I've kind of mentioned, it's quite common. You'll also see a lot of this, like a lot of people will use condensation under the oil filler caps and not necessarily the catch can as an indication that we may have head gasket failure. In my own experience, that's not necessarily a really good guide. What we're going to see, particularly if you've got an engine that is started and only run for a brief period of time, isn't allowed to warm up fully and then shut off. If that happens relatively frequently without a significant run, it doesn't allow enough time for the water vapor to actually be burned off. So it's quite common for that to occur. And yes, you will get some water vapor building up in the catch can, not necessarily an indication of an engine problem there. Mark has asked, I see a lot of American engine builders fit crank-powered crankcase evacuation pumps, which apparently can increase horsepower due to the general vacuum creating better piston seal. I almost never see these being used on modified engines from anywhere else in the world. Why is this? Okay, so the vacuum pumps that you're talking about, I guess I would refer to them maybe as a poor man's dry sump pump. So it kind of works on the same principle that I was talking about with the scavenge stages on the dry sump pump. What we're trying to do is reduce the blow-by gases, evacuate the sump. Ideally, in the perfect world, we want to be able to draw a vacuum in the crankcase. As you mentioned there, this does improve can improve piston ring seal. The other aspect, though, is because we are reducing oil vapor hanging around in the crankcase, this can also reduce windage losses where the crankshaft is physically smashing its way through oil vapor as it rotates. So it's pretty well documented that a well set up dry sump system can improve power over a wet sump system. And basically what you're talking about there with the external vacuum pump, it's just one step closer to achieving that. I haven't personally run one of these. I don't know why they aren't more popular. You do need to be a little bit careful here though, because if you are still running a conventional oil pump rather than an external oil pump, you need to be a little bit careful about exactly how hard you try and pull a vacuum in the sump, because this can affect the ability for the factory oil pump to operate. Gavish has asked, so deleting the Pcv valve and directing that port to a catch can is okay to be done. There's so much confusing info about deleting Pcv valves. What's your take on the breather ports when going with a dry sump system in regards to pressure or vacuum? Okay, a few questions in there, Gavish, so let me try and deal with them one at a time. So definitely removing a Pcv valve and just simply using it as another breather into a catch can, very, very common. I will add the caveat here that in some parts of the world where emissions compliance is quite stringent, you'd want to check, because using an atmospheric venting catch can may be problematic. Obviously, if we are removing that Pcv valve, where the Pcv valve normally would return into the intake system, that also needs to be blanked. I'm guessing that should pretty much go without saying. And just in regards to emissions compliance, we can still get a better than factory result by using an aftermarket air oil separator system. So this just does a better job of removing the oil vapor out of that air and then reintroducing the blow-by gas predominantly as just air back into the intake system. That's going to be better than stock. Okay, in terms of your other question about breather ports when going with a dry sump system, there's a lot of information about this. I've personally had experience on a number of high boost turbocharged engines, so I can speak to that. How we set up that system on my own 4G63 drag engine was that we ran 2 rocker cover breathers, but we used one-way valves in those rocker cover breathers. Now the reason for this is that at idle and at lower RPM, as we came through the power curve, we would still have a vacuum in the sump. So this allowed the dry sump, the scavenge stages of the dry sump pump to still pull a vacuum in the sump. However, with 50 plus PSI of boost, pretty much no matter what you're doing with your ring seal, you're going to end up with blow-by, and this still created positive pressure in the sump. The one-way valves in the breather system on the rocker cover then were able to open, so it was just helping to evacuate more blow-by gas. The main breather system, however, is off the reservoir for our dry sump tank, and we kind of treat this much like any other oil catch can, in that if there is an engine failure, we can end up pushing oil out into that, so we need to consider that with where it's mounted. What I would suggest, because there are quite a few, or there is quite a lot of information to keep in mind with this, is that if you check, I know for example Peterson fluid systems have a lot of literature on their website about how best to plumb your dry sump system. Lastly, before I move on from that question as well, if you're running a naturally aspirated engine where we aren't going to end up with the amount of blow-by that we would see with a high boost turbocharged engine, it's quite common with a dry sump system to use a vacuum regulator on the rocker cover. So the idea behind this is that it will open at a preset amount of vacuum to control or minimize, or limit I should say, the amount of vacuum that the scavenge stages can pull. And the reason for this is if we consider running our engine out to very high RPM, maybe 8,000 or 9,000 RPM under wide open throttle, we're getting blow-by going down into the sump, so the scavenge stages are able to evacuate that, probably still pull a vacuum. However, if we jump off the throttle, maybe at the end of a long straight and the engine is on overrun, we're still at 8,000 RPM or 9,000 RPM, wherever we may be. The scavenge pump is still spinning that fast, or however fast it's geared to run, and now there's a much lower amount of blow-by because the engine is now not under power. So this can end up instantaneously drawing a much higher vacuum. So this is where that vacuum regulator comes in. Sorry, long-winded answer there, Gavish, but I thought it was probably important to get that out. Ozben has asked, if you were to run a trunk catch can, as I've said, what would a typical hose or hardline size be, and would the distance dictate this? It's not really the distance. What we really need to do is consider the overall size of all of the breathers on the engine and make sure that the cross-sectional area of our breather hose is sufficient to account for this. I wouldn't have a size in mind, but the ones that I've used and the ones that I've seen end up being pretty large, probably somewhere in the region of about 1.5 inch OD or thereabouts. So the other alternative, of course, is you can run multiple lines to your catch can in the boot or the trunk. It's really dependent on your own preferences and what's going to be easiest for the situation. Manuel has asked, what about rotary powered cars with two-stroke in the fuel system? Luke's also asked, do rotary engines need a catch can? Okay, so two separate questions there. So Manuel's question there, it is quite common with rotary powered engine to do away with the factory oil metering pump and to run premix in the fuel. And it is essentially exactly the same as what I talked about with our piston engines. If we're introducing oil into the fuel system, this can reduce or will reduce the effective octane rating of our fuel mixture. With a rotary engine, this is a necessary evil though. Even in a stock rotary engine, they do run an oil metering pump which physically injects oil from the sump into the combustion chamber effectively, or into the rotor in order to lubricate the seal. So we're getting exactly the same effect. It's just that using a premix in our fuel, make sure that we're getting consistent and and even distribution of that oil to lubricate all of the parts. Luke, though, your question about do rotary engines need a catch can? Yeah, they're no different. They still will end up breathing, and it is still a good idea to have a catch can. Maybe, in my own experience, not quite such a significant issue compared to a piston engine, but still definitely a consideration. Bruce has asked, what's the difference between an oil catch can and an air oil separator, and in a typical setting do we need both? Kind of touched on this, but just to reiterate, an oil catch can is just physically a catch can. It is just a can where all of our breathers run into, and generally that will be vented to atmosphere. So we can end up with that catch can filling up with oil over time. The oil air separator, on the other hand, does reintroduce the blow-by gases back into the intake system. It uses a series of baffles to help remove the oil droplets out of that blow-by gas, so that we're predominantly reintroducing just air into the intake system, reducing the amount of oil being dragged with it. Evo Geo has asked, can excess blow-by blow out the rear main seal or any other main seal in the engine? Look, in my own experience, I have never seen that. I can't say that it would never happen, but you're probably going to have much bigger concerns before you worry about actually pushing out one of those seals. Anyone who's actually tapped out one of those seals would know it does take a reasonable amount of force, and there's only a very small surface area that the blow-by gas would end up acting on. So yeah, I doubt it's a big issue. Dave has asked, MAF versus MAFless catch can setups, is there an issue with crankcase and valve cover being vented to atmosphere on a MAF vehicle? Okay, so this is a potential issue that I've heard talked about quite a lot. What we do need to understand, though, is that the mass airflow sensor, regardless of the catch can arrangement, the breather arrangement, is metering the amount of air that's making its way into the cylinder. And the important point of this is that the ECU needs to know this massive air so that it can calculate its fuel requirements in order to achieve a specific air fuel ratio. So basically it knows what load the engine's under. If we are then venting blow-by gases to atmosphere, they're not being reintroduced into the intake system, you will be finding that this is obviously happening during the compression and power strokes of the engine. So it's not actually having any effect on the metered air that's making its way into the cylinders that the engine needs to know about. Personally, I've run both systems and I've had no issues tuning either. I can't say for sure right now, but it's quite likely that this could end up having some effect on your mass airflow sensor calibration. But if you're tuning the engine as that breather system is configured, it's going to have little impact on you. Jay's 22B has asked, I have a twin catch can system and one can catches good oil and the other seems to catch the water crap. It's an EJ255. Any reason you can think of that explains this? Probably don't really have a specific answer for you there, I'm sorry. Yeah, it could just be what breather is connected to which catch can, and one may be more prevalent to pushing out water vapor as opposed to oil. I'm not too sure there, sorry. Craig has asked, would it benefit to modify the rocker cover if they have no baffles installed? Yeah, absolutely. That's something we have done in the past as well. Clearly, you want to be really careful if you are going to modify a rocker cover like that, add your own baffle plate, because you want to be absolutely certain that whatever fasteners you use to secure it are not going to fall out and end up going through your engine. You're going to end up doing more harm than good if that was the case. Mark has asked, I mentioned monitoring crankcase pressure for problems. Are there any crankcase gas flow sensors on the market, and does anyone use them? Using one would be a far better indicator of problems than a pressure sensor. Yeah, absolutely, Mark. And my understanding is that yes, there are. They're actually called blow-by meters, and essentially they're a flow meter that measures blow-by gases. I haven't personally seen one of these being used on an engine. From what I've seen, what I understand, they're more often incorporated in an engine dyno cell while the engine is on the dyno. I haven't seen one of these, so I can't tell you how bulky or heavy they are. Depending on that and obviously the cost, it's possible that you could install one permanently in the engine bay, just not something that I've personally used. I guess the upshot of that is we are kind of seeing a correlation. We will see a correlation between crankcase pressure and blow-by airflow or volume flow. So that's the correlation we're trying to look for there. And again, if we're monitoring that crankcase pressure over time, we've got a good baseline of what the crankcase pressure is when the engine was freshly built and just run in. We can then see if that piston ring seal is going away. Armour Autosport has asked, is there any added power from better ring sealing from pulling a vacuum on the crankcase, maybe more of a natural aspirator concern? Yeah, so we've talked about that before. The two benefits there are the potential for an improvement in ring seal and the reduction in our windage losses. Mariano has asked, if you had to mention one major negative besides oil residue making its way into the intake system due to blow-by, what would it be? Well, I think probably the biggest issue with a system that rebreathes, as I've mentioned during the webinar, is the effect of that oil vapor potentially reducing the effective octane rating of our fuel. So if you've got a really highly strung engine, this can result in detonation. So that would be my biggest concern. Andrew has asked, with my SR20 DT block mated with a VE head, I'm returning oil from the catch can at the bottom drain port to the hose connected to the crankcase vent. Is this a good idea? My main thought was to not have to drain the catch can. The upper ports of the catch can are connected to the 3 ports on the valve cover, or the -10AN. Okay, so really this comes down to what I've already said with our FA20. Yes, you can do it. On face value, it seems like a great idea until you actually see how much water vapor and muck is basically stuck in the bottom of that catch can after use. So personally, I changed my tune on that, and my preference is to actually just drain that out of the catch can and get rid of it. But have a look sometime at what's coming out of that catch can, and then you can make up your own mind. All right, guys, that's brought us to the end of the webinar. Some really great questions in there, so thank you everyone who did get involved with that discussion. Hopefully it's given you a little bit more understanding on what may on face value seem like a pretty boring topic, but hopefully it's also given you some more idea on what you can look at to confirm if an engine that seems to be breathing heavily may in fact be exhibiting some potential for damage. As usual, if you do have any questions after this webinar for all of our HPA members, please ask those in the forum and I'll answer them there. Thanks for joining us. I look forward to seeing you all next week. That was just a taste of what we put on every week for our HPA Gold members. We've currently got over 240 hours of existing webinar content covering topics on engine building, engine tuning and wiring. Click the link in the description to learn more.